Okay, so I'm Norbert. This is not my first Wrocław rodeo. I've been here before. There's like 2 or 3 people in the audience who know who I am. The rest of you, maybe it's better that you don't. I was here in 2015, and I gave a talk about how, as a Ruby backend developer, I have reignited my love for front-end development when I've discovered that there's this thing called ClojureScript in React. And it turns out that front-end development isn't crazy. It's just that the tooling was. And if everything is just view equals function of data, then everything becomes nice and pleasant. And it actually turns out I actually enjoy front-end development. And then I came back 2 years later, and I told you guys that, listen, I've been to the woods and I'm coming back. And it turns out that you can even do backend development with Clojure and immutable data structures. And it turns out that you can build entire systems in this, and it's not just a front-end thing. It turns out you can build everything in it. And there's all this great tooling with ClojureSpec and stuff that gives you the equivalent of what type checkers give you without some of the hassle that type checkers give you. And then, as it goes, 2 years later, I went to Pivorak in Lviv, and I gave a talk about how it turns out not only can you do front ends with this, you can do back ends with this, but you can also replace your database with this concept of what happens if you just have immutable data and you have this data flow concept and that's all you've got. How would databases look like? And it turns out that they look really nice. And this is actually, Pivorak was really awesome because they made a really nice recording. So if you want to find out more about how you can replace your relational database or your NoSQL database or your front-end Redux state machine with something more sensible that actually scales with how your domain changes over time, then I highly suggest you go check out this video. And I decided I'm not going to give you this talk because you can just go and watch it on YouTube. So we are here, right? New slot, new talk. And I sort of wanted to close the loop because I did something about front end, I did something about back end, I replaced my databases, and it turns out that the only missing piece is APIs, right? Because then we sort of have a full picture and I can just go home and write Lisp all day long. So this is a talk about how to build APIs using these ideas that I've been basically telling anyone who would listen for the last 5 or so years, right? And you know who you are. So there's a recurring theme, right? What is the recurring theme, except for the fact that I'm here every 2 years? The recurring theme is someone tweeted this photo last time I was here with a caption that read, "When you use Clojure and haven't told anyone for 5 minutes." And I was really disappointed, and I will tell you why. Because they completely missed the point of my talks. Because this is not what is important. If they had tweeted this, then I am guilty as charged. Because my face looks exactly like that, like a vein is popping out every time I hear people describing their problem, and it turns out that they could just use declarative data structures and simple functions to solve their problem. That's exactly how I look. And anyone who has talked to me at after party knows this to be true, right? And so the question that remains is, how can we take this approach and sort of build APIs with it? And so I tried to bring it down to something that is like a 4-step process, because if it takes more than 4 steps, nobody's going to do it. And so I came up with this. I'm not sure if it's totally relevant, but we're going to give it a shot. And so the question is, how do you build an API with these concepts of immutability, EDN, context-free, and flat? And don't worry, we'll get into it. So we need an API. So YouTube, why not, right? As good as any API. This is what YouTube looks like if someone has been living under a rock for the last 20 years. Single page app, lots of stuff going on here, right? So imagine if you're a front-end developer and you have to build this single page app with all of these weird interactions. And now imagine that you're the only person hired at YouTube, so it actually turns out you have to also be the backend developer who handles all of the requests to render all of this information. And that's what we're going to try to solve today. So we're going to blur out the details because they're irrelevant, and we're just going to look at the structure. What's happening here? Well, first of all, we're getting a bunch of data from the API about what is the video and all the details about how to actually render the frames and just run their actual process of watching a video. But it turns out that there's a lot more going on here because there's video details, which is things like the titles and how many likes does it have, how many views, all the share links, and all this kind of stuff related to the actual video metadata. And then you have a channel, which could be a user or it could be a physical channel. It turns out in the YouTube API, user equals channel. There is no separate concept for a user. And this idea of a channel means that on this view, you have to render and fetch a bunch of data about, like what is the channel title, what is their avatar, how many subscriptions, how many subscribers do they have, and all this kind of other information. And then here on the bottom, you have basically an infinite loading screen of comments, right? Depending on how popular a video is. For each of those comments, you need to load a bunch of data about when it was posted, what is the body, and who did it, who wrote this post. And it turns out in order to render who wrote this post, you actually need to render their name, but also things like their avatars, since when are they like a user of YouTube, and so forth and so forth. And if this wasn't complicated enough, there's all these things on the side here, right? There's this little div all the way on the top of there that says next video that I'm going to show you. And in order to render that little div, you need to know things like what is the video title, what is its thumbnail, and YouTube tries to explain why that particular video showed up. So it'll show you things like how many people are subscribed to the channel because they gave you this to the feed because it's a popular channel, or a lot of people similar to you watched this video, or a million other reasons, a million other data points that need to be fetched in order to do that single video, and then repeat it for all the other videos in the feed, right? All of this data needs to be fetched in order to render this single view. And it's not a dashboard, it's a page for a single view of a video. So, how would you do this? Well, if we're in REST, it would look something like this, right? You basically fetch the video, fetch the channel related info, fetch the comments for each comment, fetch the author information, fetch the next video, fetch its channel information, and so forth and so forth. So obviously nobody does this because YouTube would take forever to load and render, and then it would probably put the, like the backend system down because of the amount of data fetching for a single view. So nobody does this. What YouTube does is it does this. Does anyone play with the YouTube API? So imagine what is happening here. They've realized that they can't give you all the data, so they call this thing called a part. And they say, different pieces of information are in different parts, and you need to fetch the right part to get the right information. And even on top of that, we're going to even add like little quotas. Like different pieces of information are more or less, I don't know, hazardous to our health, so like our backend server, so they're going to cost you more quota points. So does anyone want to take a guess? If I wanted to get the channel title, this is a channel API, right? So like get channel, which part would I need to send as my parameter to get the title? Is incorrect. It's not content details, it's not content owner details, it's snippet. YouTube has this concept of a snippet, and snippet in air quotes is the most likely information you want to fetch for a specific entity. Yeah, so there's that. So REST is dead. Let's move on. I'm not even going to discuss this issue. So if you don't have REST, what do you have? Well, obviously YouTube is not the only person with this problem. Facebook has this problem. They made GraphQL. Netflix has this problem. They make Falcor. I'm going to talk about GraphQL more just because I feel it has more market share, but they're pretty much identical except for some slight implementation differences. So how does GraphQL solve this problem? Basically, you define types, and you say, a video type has things like an ID, a title, a description, has a relationship to a channel, to next videos, and so forth. And then you define what it means to be a channel, and then you define what it means to be a comment. And once you have all of these types down, you can write a query. And this is what a query would look like. It would just be basically saying, given a scope of video with some ID, here are all the attributes I'm interested in to render this web page. And it would be things like ID, title, description. And notice what's happening here with the channel and the comments. It's using a map notation to say that we're going to be joining a relationship with something else in our system, right? And same thing for next video and related videos. And it turns out that's all you need to render this really complex web page. And so this is wonderful compared to Rust. I mean, this is a huge step up. And it primarily works because it puts all the control in the hands of the client. So first of all, the client is responsible for describing exactly which pieces of information it wants without having to understand that there's a snippet and content details and all this other stuff. If you only want the title, that's all you're going to get back, nothing else. The second thing is that once you build a client and the server keeps adding new features, the API keeps adding new features, you're never going to break old clients. Because if you add new features and you give them new names, new attribute names, old clients are not going to ever request new features. So by definition, they're never going to break as long as you never remove old attributes. You just always add new ones if there's new features you're interested in. And the other wonderful idea behind GraphQL and the fact that it's controlled by the client is that you remove tons and tons of boilerplate. Because a lot of code that's written on the front end is unfortunately nothing more than fetch this arbitrary API endpoint that's going to give me back a blob of JSON and map that blob of JSON from the documentation to the things that I'm interested in, right? So that's exactly what you do with YouTube. You say, I need to read the YouTube documentation. I need to know that I need to ask for the snippet, and it's going to give me the snippet in some really weird arbitrary JSON structure, and I need to know to fetch that specific thing to actually get the video title. As soon as you have a GraphQL system, this problem completely disappears because the client, by specifying the structure of the query it wants, is going to get the exact same structure back. So it turns out that you get the exact same representation back to you, right? No questions asked. So there's no boilerplate related to how do you build these systems. So it's wonderful. And this will be the end of the talk, except GraphQL isn't perfect. It has certain problems, and all of them basically boil down to this. The idea of the type. So you can't define arbitrary attributes in GraphQL. You always have to scope it to a certain type of thing that it's designed for. So imagine you build an arbitrary comment React component that is only interested in author, title, and body. You can't arbitrarily ask a server for, give me all the comments for videos, users, and channels, and use it as if it was, from like a UI perspective, you honestly don't care if this is a comment from a video or a channel or a user. It has the exact same semantics. It has an author and body attribute. But unfortunately, in GraphQL, you actually need to create 3 different types because the attributes themselves are always nested within the scope of a specific type. So you get type explosion. You get the exact same problems anybody has ever seen with any kind of type system that doesn't allow for basically interesting ways of expanding the types without basically rewriting the code millions of times, right? GraphQL gives you tons and tons of type explosions, which is, you don't see it in Hello World programs, but you see it when you build big applications. Anytime you want to design a different kind of scope for a query and keep the same attributes, you need to create a new type, right? So this is an explosion of types. But we can solve this problem. Well, GraphQL won't save you. And since this is a Ruby conference, and I'm a Clojure developer, you have to give the standard Rich Hickey quote of, you solve this problem by decomplecting it. And for anyone who isn't familiar with this quote, basically, decomplecting is the process of taking things apart that were unintentionally coupled together, but really don't need to be. And at this point, I'm sure DHH is writing some diatribe somewhere about why this is wrong. And where's Grzesiek? You know where you are. Okay. How do you decomplect this problem? What are the things that are completely independent of each other that shouldn't be together? Some ideas. One more time? No, comments are part of the video. And so if you remove the comments part, then basically you're going back to rest. Nope, same problem as comments. It's part of the video. It's this part. It's the scope. There's no reason why the scope is part of the query. The query describes, this is the stuff I'm interested in. The scope describes, how do I get the thing? and then pull out the data that I'm interested in. GraphQL doesn't do this, but it turns out if you do it, then you get a lot of interesting properties that fall out. So that's essentially what EQL is. But if you sort of squint at it a little, what is this? This idea of here's the thing I have and here's the thing I'm really interested in. If you squint at it just a bit, it looks like something that you do on a daily basis. And it's called select keys. Or in Ruby land, it's hash slice, right? It's this concept of here is a hash map of things I have, and here's a list of keys I'm actually interested in. So give me a new map just with those things and nothing more. This is essentially what we need to do at an API level. And so it looks something like this, right? Like I have a map with ID and title, but I'm only interested in the title, so select keys will give me exactly that and nothing more, right? This is simple enough. So that's select, but what about traversals? Does hash slice give you the capabilities to say, I want the title, but I also want the body from the comments field, right? Hash slice doesn't give you this concept. Select keys and closure doesn't give you this. It doesn't have the proper notation to describe traverse into a set of vectors and maps and give me the specific thing I'm interested in. But there is something that does this, and you might also use it on a daily basis, and it's called JQ. Who here has heard of JQ? Right? This is exactly what JQ does. JQ says, here's this weird Perl-like string notation for how you pull out things from traversals, right? And it gives you the thing you're interested in. But even JQ can't solve the problem of derivation. So derivation is the idea that if I have the ID and title, I'm interested in the title and the URL. And you might ask, how do you get the URL? It wasn't in the context, but it is, because a URL is nothing more than a string concatenation of some base URI and the ID. And the ID is something you do have. So JQ, I mean, as far as I know, doesn't give you the ability to derive new kinds of data, although I might be wrong because they have some really crazy stuff on that website. But it's definitely not something I can sit down at a terminal. I don't know what the notation for derivation of functions in JQ is, and I tried to look for it in 10 minutes on the tutorial, and I couldn't find it. So it might as well not exist. But this is essentially what we want to do at a higher level. We want to basically be able to write something like JQ with a proper notation to give you selection, traversals, and derivation. And ideally, you don't want to use a string notation because a string notation like SQL, like GraphQL, is really hard to modify programmatically. It's something that you have the same problem with SQL. You can't programmatically manipulate it, right? You always have to build some concept on top of it and then sort of push it back into a string, which is a real pain in the ass. Okay, so now we go back to the beginning. Let me check how I'm on with time. So the question is, how can we build something like this using these concepts? And it turns out, conveniently, there is a Clojure library already that does this. It's called Pathom. And I'm going to describe it to you. And the trick is that not that this thing exists in Clojure and we use it on a daily basis. The thing is that the ideas behind this aren't hard. And there's no reason why you shouldn't be able to just port this to Ruby, because I think there are a lot of nice consequences from doing this. So the first thing is immutability, right? It's like, this is our cornerstone. Let's figure out how much of the stuff we do is stuff that is moderately side effect free, and let's push everything that has side effects and I/O to the edges of the system as much as possible, because it makes everything else easier to test. So if we want immutability in the API, basically it comes down to this. It's the idea that we have some arbitrary parse function that has a context and a path, and that's all. Anything, and the assumption is that if the path wants to describe some bit of information, the context needs to feed it in. There's nothing else coming into the system to make any kind of decision. You need to sort of pass everything in through the context. So that's simple enough. The second step is let's use Eden wherever possible. Well, it turns out that's really easy because basically we're going to replace path, which is arbitrary, with EQL, which is a very specific notation. And this is actually how I approach problems. I basically say, how much of this stuff can I make immutable? And then how much of this stuff can I describe in Eden? Or in this case, EQL. Because what is EQL? It's the Eden query language. It's Seems kind of obvious, right? What is Eden? It's the extensible data notation. Aren't you happy there isn't like a third slide with more acronyms? But what is this really? This is what it is. It's a data notation. It's literally how do we express things as data in such a way that you can put on the wire, you can serialize it, and then you can deserialize it back into programs. And it's a notation that describes things like how do I serialize things like numbers and rationals and decimals and big integers? How do I serialize things like instances and date times, booleans, nil, string, keywords, symbols? Like these are examples of scalars. And then you have examples of collections, things like vectors and sets and maps and lists, right? And Eden is basically a specification that says these are the kinds of things we're going to support, and here's the protocol for how to serialize it and deserialize it, and so it's cross-language compatible, right? There's like an Eden parser for Ruby, there's one for Java, and so forth. Now, if this looks a lot like Clojure, that is no coincidence, because Clojure uses Eden as a way of expressing Clojure programs. So essentially what Clojure does is it says, given an Eden-like file, I'm going to use this representation to compile it into an AST, which compiles it to bytecode, right? So it's no coincidence that this looks a lot like Clojure, but that's not because this is Clojure, it's that Clojure uses Eden as a way of writing its own programs. But it turns out that Eden is useful besides just Clojure, right? Because we use it everywhere as a way of communicating between services, as a way of storing stored procedures and databases, as a way of storing any kind of configuration and so forth. You can think of it as basically a safe YAML because it supports extending it with custom types, or you can think of it as a JSON++ because it supports things like vectors and lists and sets, something that JSON doesn't support, or you can serialize things like instances, which is something you can't do in JSON, right? So basically the way you think about it is this is all the kind of data that we need to basically store any kind of information ever. Okay, so that's Eden. So what is the Eden query language? Well, it could look something like this, right? So when you look at it, oh right, I didn't mention one thing. Keyword and symbol is flipped, right? Compared to Ruby. I don't know why Mats did that. Ruby was inspired by Lisp and all these other languages, this is a keyword and this is a symbol. But for some reason in Ruby, it's the exact opposite of what is a symbol and what is a keyword. But that's irrespective. So this is called a symbol in Ruby, right? Yeah, and I don't know why he did that. All the other languages do it the other way. So keyword is something, what is a symbol in Ruby, and symbol is basically like if and def and things like that, like things that are constants in your language of choice. Okay, sorry, just tangent. This is GraphQL, and this is what EQL could look like. So the only things that really changed was we switched from an arbitrary string notation to using data structures, which is nice because it means that you can manipulate it using code. We basically, instead of some arbitrary string identifier, we just use keywords because they're things that are programmable. And notice that what happens with things like channel and comments is you use a map to describe the fact that you're doing some kind of a join. So you're using vectors to describe lists of attributes, and you're using maps to describe this is a join of some kind of a relationship. So in the simplest case, this is what it will look like. And except for the convenience of having a programmable data structure, this is probably not enough of a good reason to switch. But there's more, because we're just on step 2 out of 4. Number 3 is context-free. Whenever possible, we strive to build context-free systems when describing our data. What does that mean? What is this? It's an ID. It's an identifier. What is an ID for? We don't know. We don't know because we're missing some context. But it turns out that you can uniquely identify things without putting it into context. You can give it a namespace. right? Eden supports this concept of namespace keywords. And as soon as you do this, you know exactly what this is. If you see this somewhere in your code base, you don't have to ask, what is this an ID of? You know it's a video ID, right? The namespace tells you exactly in which context it's being used and what does it represent. And you will never confuse this with a user ID or some other kind of identifier. And so when we apply this kind of transformation, this is what our query starts to look like, right? You have a bunch of like things like, this is a video, I want some video ID. Notice that I can look at channel title and I know exactly what it is without even looking where it came from. Like, what is the relationship from everything else, right? I just see channel title and I know exactly what I'm looking at. Now, this is already much, much better because we have context-free identifiers, but we can do even better because if I see video ID in my system, I may not know exactly what I'm talking about. Because if I'm some kind of video aggregation service, this could be a YouTube video, this could be a Vimeo video, this could be some video that was uploaded from disk. So to make it, let's just make it super explicit and let's just call it a YouTube video ID, right? And we'll see later why this is important. So now our code looks like this. And yes, it looks a lot more verbose, I admit. But the nice thing is it's completely context-free. And you don't need, you basically always know where you are in the system. And so now we can apply the fourth rule, which is once you have context-free identifiers, you can flatten things. And that has a really interesting property. This is what happens. Notice what just happened here. At the same level as a YouTube video ID, I can ask for a YouTube channel title. We've lost the necessity to do a join because a video has a 2-1 relationship to a channel. It always is uploaded to a specific channel. So at the level of an API, I as an API user do not need to know that there is some kind of relational database that maps videos to channels. As far as I'm concerned, a YouTube video and a YouTube channel title is all on the same level, right? Just like it is in the web UI. The only things that need to be still created with a relationship join are things where it's a too-many relationship, because you can't flatten a too-many relationship. You need a vector of things. Does this make sense? Perfect. So we've been ignoring scope up to now. And so the question is, how do you do scoping? Well, it turns out you've already been doing it, you just haven't realized it. This is a scope. Any kind of a map that is a join is a way of scoping information. It's saying, I want the comment body and the author title, but the scope is the key of this map, right? So it's, I want this for the video comments. And the way you implement this in Pathom is you basically do this. You say, give me a resolver. I want to create a new resolver. The input is, if you give me a video ID, I have a function here that knows how to return comments and body and title specifically of the comment. So what I'm creating here is I'm creating nodes in a graph that says, if you give me a video ID, I can give you this data back by calling this function. And this function you can just imagine is just calling the YouTube JSON API and basically just fetching the data we're interested in. So that's one thing. The question is, where does a YouTube video ID come from? Right? Well, it turns out that the resolver doesn't care. When you're building this resolver, all you care about is that I have a video ID, I know how to get comments. I don't care where the video ID came from. I no longer have global scope. I no longer have type explosions. Basically, any way you can give me a video ID, which is tell me what video ID it is, or give me a playlist ID and I'll fetch all the video IDs related to it, or any other kind of method of getting a video ID, at this point, I don't care. This is just a graph in the node that knows if I have a video ID, I can get you comments. And that's all you do. But at some point, you're going to have to build that top query. Like how do you even begin to build a query if you don't have some kind of root scope, right? So the question is, what kind of root scopes make sense? Well, there's only 2 of them that really make sense. One is, I have a specific identifier, and I want you to start there. So it's a tuple it's a 2-element vector that says I have some ID, And based on this ID, I want the title. And basically the implementation, this is the entire implementation in the code. It basically says, here's the input. This is the stuff I can guarantee if you give me an ID with this function. And that's it. And honestly, it doesn't matter where in the query I'm asking for a video title. If I have a video ID, I can do your work for you. And the other kind of thing you might want to do in a root scope is basically a singleton, a global identifier. So you're not scoping to a specific video. You're basically saying, there's some concept in our API called favorite videos. Maybe basically we look at the user session and we figure out how to fetch the user favorite videos and then get the video title. So how do you implement this? Notice there's no input because it's a global singleton. It just says that if you're asking for favorite videos, I know how to get you an ID. And notice that we're asking for the title, but that's okay because we already have a different resolver that given an ID, will know how to get the title. Okay? Next thing you might want to do is you want to do some kind of parameterization. And this is where, so like you want to give it like some limits and some searching and stuff. And so that's where this Eden list notation comes in, because it's a way of telling the data structure, this is a way of parameterizing the thing I was already asking for previously. And again, the implementation is actually identical because basically the params are just part of env, and you can sort of fetch them, get them out if you are interested in them. And the last thing is mutations, right? Because GraphQL, except for doing reads, actually does writes, and it has ways of sending commands. So it turns out that all you need to do in Eden is use the parentheses and a symbol. We haven't used symbols up to now, but because we have symbols in Eden, we can actually specify completely different semantics for it. So anytime it sees a symbol, new user, it's going to look for like a CQRS command called new user, give it the following commands, and execute that specific thing. But what is this doing down here with a command? This is a join that basically says, here's the command, here's the mutation I want you to do, and here is the read I want you to do after you finish the mutation. So this gives you the ability to send mutations with read after write semantics, right, for free. And the implementation is basically this, def mutation with some params and the output. So this gives you the ability to say, do the mutation after you have succeeded, do the original query I was asking for. And you have read after write semantics for free. So I know this is really boring, but I want you to show you something, because maybe it'll be easier if I just show you. Here's a little application that lets me write queries in the system. I'll just do some copy pasting to make this faster. So what's happening here? I'm fetching a YouTube video ID. I'm specifying the scope. The scope is a YouTube video ID, and I want the snippet title and the statistics view count. And basically, what's happening here is I'm getting back the video ID, the snippet title, and the view count from my 2015 talk, right? So far, so good. So basically, what has happened here is I've written an application that parses the Pathom API and parses the Eden I've been talking about to this point, and basically just does a resolve by calling the actual YouTube API. Nothing more. So that's simple. The other thing you can do is if you can, of course, replace this with the globals, which is like my videos, right? So this is some custom endpoint, a custom resolver that says my videos is basically some arbitrary 3 IDs in the database. And what it does is for each of those IDs, it fetches the title and the view count. Now, you may have noticed that this editor actually sort of tells me what things I can reach from the place I am, because essentially my videos is a resolver that says, here is a list of video IDs that I'm interested in, and this says that given you have a video ID, these are the places you can reach, right? So one thing you can do is you can reach the channel. How would I reach the channel? Let's go back to that previous one. So the YouTube API, when you call the video details, will return something called a channel ID and a channel title in their snippet, because they figure that this is the kind of information that is used often enough that we're going to add it as part of the video API. But what would happen if I wanted to also get the channel view count? You would get a not found. Is this legible enough for everyone to read? Okay. So why is this happening? Because the people at YouTube, when they were writing their API snippet concept, they figured channel ID and channel title are used often enough that we're going to add it as part of our video payload. But they never considered that view count is something that is relevant enough, so you can't actually fetch it. You need to make a separate fetch, REST fetch, for the channel title snippet, the channel snippet stuff, right? But this right here is the channel ID. So if I create a resolver that aliases this to the channel ID, and I've actually done this, so this returns, right, correctly. This returns the correct ID. And the way this resolver works is basically says, if you have this, I will give you this. And all it does is it's a one-to-one mapping. But once you have this YouTube channel ID, you can resolve anything that was related to the channels themselves. So you can do something YouTube doesn't let you do, which is in the same query, say, I want the video count and the view count for the channel itself, right? So there's 116 videos on the channel title. So the channel Wrocław RB has 116 videos, and that's its statistics for its view count, even though I'm scoping it to a YouTube ID, right? And maybe it'll be easier if I show the tracer. So what is happening here? These are the things I'm interested in, and it turns out that calling the video API, I can get the channel ID and the snippet title, but as soon as I want the video count, that's not part of this API call. So it needs to do a second API call to get the video count and the view count for the channels. And the way this is working is it basically just builds a graph of all the kind of attributes and the ways you can reach those attributes. And then it figures out the minimum amount of API calls it needs to do to get all the data you're interested in. So same thing as for playlists. So here's a playlist ID, and I'm just going to give, get the title and the channel. And what you're seeing is it's just a single API call to the playlist API. But similarly to how channels and videos work, if you're in a playlist and that's your scope, the playlist ID knows which channel, the playlist returns something called the channel ID. And if I create an alias and say, this is actually the same as if you would just said YouTube channel ID, then I can get any information about the channel itself. And I can also fetch, join and fetch the items. And then from the items, get things like the video stuff. And so at this point, I'm basically fetching all the videos for a playlist, Wrocław RB 2018, and I'm fetching its titles. And if you look at the API call, what it's doing is in parallel, it's calling the video stuff, it's calling the playlist API, and then it's only calling the channel by ID when it knows which channel it's related to, and it needs to resolve the video API before it can do that. But once it does that, notice that there's like 4 or 5 videos, but it only does a single API call because it knows that it can batch, because YouTube supports a batching API that says, if you give me a list of video IDs, I can get the video ID and the playlist snippet title from that. Which, co tam, Adam? Like 4 more minutes. I'll show you something cool. I promise. This is the same query. Look at what's happening here. We're starting with a user, Wrocław. We're fetching the channel title. Then we're joining the playlist. We're fetching all the playlists related to Wrocław RB. We're getting the title of the playlist. We're fetching the items for the specific playlist. And for each of the playlists, we're fetching the video titles. We get lots and lots of data back. And notice what the semantics of the API call is. We needed to fetch the channel. We needed to do this query before we could get anything more done. Then we needed to fetch the playlist. But once we did that, notice that in parallel, we can fetch all of the different playlist items because they're unrelated to each other. By building honestly, this is no more code than what I showed on those slides. The def resolver, all it does is it just says, given this attribute and these kind of attributes, I know how to get from here to here, and you build this graph in memory, and it knows how to batch and correctly resolve this using the minimum amount of API calls it needs to do. And one more interesting thing is HTTP errors. So this is that video I showed initially. And I'm fetching file details. File details is something that I don't have access to because I was not the uploader of the video. And so what happened here, and maybe this is even more relevant if I just do it here. So notice what happened. I hit the YouTube API. I got a 403. So I hit it again with a 200. What happened? What happened was that the first time I hit it, I tried to fetch the part file details. I don't have permissions to get the file details. So it errored out. But then it realized, because I created two resolvers, one with the ability to fetch file details, one without the ability to fetch file details. So once it hit a dead end in the graph, it tried to figure out a different way to reach the things that I asked for. So it called a completely separate API that was able to return the title and the channel ID, but was not able to return file details. So for free, you get this ability to say, this is what I have, this is what I want. You try to figure out any way possible to first reach it as fast as possible. And if that doesn't work, try the backdoor. Try any way to reach the attributes. It's a simple graph traversal problem at this point. And now we get to something that's really interesting. I also integrated SpaceX API. So this is just an API that returns things like the launch year, right? Or here's a... So it just returns the launch year. And actually, it returns a bunch of other stuff related to SpaceX, right? Like the fairings recovered and launch details and everything you want related to a launch. But one of the things the API also returns is this. What is this? This is a YouTube ID. So what do you think happens if I create an alias that says, this YouTube ID is in fact the same thing as the YouTube video ID I have everywhere else in my system? It's the exact same ID. And once I have that, it turns out, and this is the reason why I use fully namespace qualified keywords, because you can integrate multiple services in one API. So imagine you're building a front-end dashboard for a SpaceX fan site, and you're saying, give me the stuff related to SpaceX launch, like the launch, I don't know, site name. And also, while you're at it, give me the YouTube title, and not the channel title. Actually, let's find out which let's find out what channel it was posted on, but also let's find out what is the title of the video itself. And while we're at it, let's find out how many people watched the video. I can't type. Video view count. So this is the YouTube video title. It was posted on the SpaceX channel, and it had 500,000 views, right? No joins, right? This is the power of having context-free identifiers. And the power of building graph APIs that, and like using all of this information from the 60s about how to do graph traversals and graph optimization problems. And by the way, this is all flat, but imagine you're building a front-end application, and sometimes you want to create additional structures for your convenience. So what you can do is you can do things like you can create, in Pathom they're called placeholder namespaces. It basically says if you see this kind of namespace, just ignore it. But what that means is you can do something like you can build a dashboard that says this is the video details, SpaceX details. And you can do a separate join because there is no such thing as a root join. You can join anywhere in the system. If I wanted to, I could start here and say my videos, right? It's completely arbitrary. They don't care. Nobody cares. And so what you can do is you can do things like this. You can say, this is the SpaceX details, and then here are my favorites. And basically here we're going to join, we're going to join this. And we're going to take the favorites and we're going to, for example, just return the, I'm going to join the fact that this is my videos, args. So from my videos, let's just get the title. As you can see, there's lots of data available. And so what happens here is the client can create, when you have a flat data structure that has context-free identifiers, the client can specify custom arbitrary nesting that makes sense for his application and his domain. And since you're not enforcing it, they can do anything they want with it. So that was that. I think we're basically out of time, which is nice because we're basically out of content. One thing I might want to mention is, because I think this is kind of neat. So this is all obviously ClojureScript. This is something called workspaces that basically lets you build, imagine you have a bunch of React components, and then this basically lets you mount, this whole thing I've been showing you is just a React component that basically triggers the Pathom API. But you can build a bunch of these like workspaces, like, like live coding of React components, and then you can create basically all these kind of views you would do in a real application. And this is all built in a framework library called Fulcro. And what's funny is, if you notice, so I build Fulcro applications, I embed them into this workspace, which is a Fulcro application that lets me embed applications into applications. And the Fulcro itself has a debugger that runs, it's called Fulcro Inspect, that basically runs in your Chrome DevTools and gives you access to things like what were the operations that were done, like what were the network calls and all this other stuff. This itself is a Fulcro application as well. So it's like turtles all the way down. Honestly, this is now when I think about it, this is what probably Rails engines should have been, because it actually works, right? And when you think about it, look at what is happening here with this concept of globally unique identifiers. Whoa. See this thing on the bottom, all the way in the bottom of our API call? This com VS code Pathom trace? That is a piece of globally unique information that was attached on top of all the stuff I was asking for, because that's what the backend returns in order to have this tracing information so it can display this metadata for me, like this tracing route stuff, right? This is the power of having flat globally unique identifiers, that you can do stuff like this, and you can basically do all this kind of stuff. Okay, I'm pretty much out of time. I don't know if I have time for questions, but I can definitely talk to you afterwards.